Welcome to the deep dive. Today we're looking at something that, on the surface, seems really simple.
It does, almost like a throwaway component.
Exactly. It's the NTI EBE2-800, which is a miniature piezo buzzer.
Right.
But our mission here is to figure out why this tiny little alert system needs, well, an infrastructure built for a marathon.
That's the real puzzle.
So let's just run through the top line specs. I mean, it is tiny. We're talking 0.61 by 0.55 inches.
Unbelievably small. It could fit on your fingertip.
And yet it's incredibly loud. It's rated for a 95 decibel output.
Which is pretty significant for something that size.
But the real kicker, the thing that makes this a deep dive topic, is right there in the model number, isn't it?
The 800?
Yeah, that's for an 800-foot cable attached to this tiny buzzer.
It's an amazing contradiction. The engineering that goes into marrying those two extremes, the tiny size and that massive signaling distance.
It's a loud sound. What is it exactly?
It's a continuous tone at 4 kHz. And that frequency is chosen very specifically.
A cut-through noise.
Exactly. It's designed to slice through the typical background hum of a server room or an industrial facility. It's meant to grab your attention immediately.
You mentioned the engineering, and I noticed the power requirements seemed really low.
They are. The specs listed around 7 to 20 milliamps at 12 volts.
Which is nothing.
It's crucial. It reveals the whole design philosophy. I mean, it can hit that max 95 dB, but that takes a little boost to 15 volts.
Okay.
But it's designed to run reliably across a whole range, even down to 5 volts where it still puts out a respectable 85 decibels.
So why is that low power draw so important?
Think about scale. In an enterprise environment, you might have hundreds of these. If every single one was a power hog, you'd put a huge strain on the central system and its battery backup. Low power scales beautifully.
Got it. And this device isn't a standalone thing you can just hook up to a battery?
No, not at all. It's what you'd call an intelligent accessory. It has no brain of its own.
So it's triggered by something else?
Right, by sensor variations, temperature, humidity, you name it. It has to be controlled and powered by one of NTI's enterprise environment monitoring systems.
The E2D, E5D, or E16D models, I see.
Correct. Or even their smaller E-I unit, but then you need an optional power supply. It's a dedicated, high-reliability part of a much larger system.
Okay, so that brings us to the cable. This is where it gets, I think, really interesting.
It's core of it, yeah.
Why on earth does a buzzer need a cable that's almost a fifth of a mile long?
It tells you everything about the intended environment. We're talking about massive facilities.
It's like data centers.
Data centers, sprawling utility plants, huge institutional campuses, places where your monitoring hub might be in one building, but the sensor and the need for an audible alert is hundreds and hundreds of feet away in another.
So how does it connect? Is this some proprietary plug?
No, and that's the smart part. It's a really simple 2-wire interface. Standard PCB mount pins.
So it's easy to integrate.
Very. But the real work is done by that pre-soldered 22-gauge wire.
And 22-gauge is fairly thick for a signal wire, right?
It is. And you absolutely need that thickness to run power and signal over these huge distances. NTI actually offers this up to 1,000 feet.
1,000 feet, wow.
Yeah. Any thinner and you'd get too much voltage drop. The buzzer at the far end wouldn't be loud enough to do its job. That wire gauge ensures power integrity.
And of course, for anyone in procurement listening, this kind of specialized engineering has a price. The 800-foot model is about $105.
Which reflects the quality of the components and, the pre-attached cable.
It also comes with a 2-year warranty, and crucially for certain buyers, it's TAA compliant.
And that's a really key detail. TAA compliance means it meets the Trade Agreements Act.
A requirement for government contracts.
U.S. government, yes, and many large institutions. It's a signal that this isn't some cheap, off-the-shelf part. It's sourced and built for critical infrastructure.
So if we tie this all together, what the EBEEP2-800 really shows us is that even the most sort of simple component like a buzzer is part of this incredibly high-spec long-distance system.
Absolutely. It's all about reliability and power integrity over seriously impressive distances.
So what does this all mean for you, the listener? The fact that a buzzer like this even exists, with a cable that can stretch up to 1,000 feet, points to environments where your monitoring system and your alert point are just separated by these massive physical gaps.
And where wireless just isn't an option, either because of interference or security protocols.
Right. So here's the thought to leave you with. What kind of critical environment demands an audible alert system that has to cover nearly a fifth of a mile without ever failing or losing its punch? Think about that the next time you walk through a truly large-scale facility.